I'm CK. A couple of months ago I tried a mini table saw. I'll put a link to that video in the description below. It was pretty good with lots of safety issues, but a lot of people like seeing it. So subsequent to that, I've been spammed about a mini drill press from a company called Innocraftsman. So I decided to buy one. I hope it's in here. If it's not in here, I'll just delete this video. We'll unbox it, take a look at the pieces we get, and put it through its paces. I can actually see a lot of use for a mini drill press, so hopefully it's a good tool. And I hope you enjoy the video. So here's the box, and we have a bunch of things. We have some wood to drill, a little piece of plastic from another kit I built, a circuit board because I can see doing that, and some metal. This is aluminum, and I'm not going to try steel today. Oh, I might. I have this little wrench that I might try. And of course, my ancient drill index, which is older than most of you. I got that in like 1982, and some of the drill bits are still the same. And most importantly, safety goggles. Never use power tools without safety goggles. You can lose a finger, that's fine. Losing an eye, not fine. So let's open this up. It's taped really tightly, and I got to make sure I don't, speaking of which, I got to make sure I don't cut myself cutting the tape loose. Because again, I think it was drop shipped to them from China, and then they sent it along. Obviously recycled cardboard. Here's a piece of foam out the top. Here's a piece of foam out the top. It's a deep piece of foam. I don't know how to get this out. I think this is the power supply. So we'll look at the power supply first. And it is output. I can't read the output. I'm sorry, I gotta step over here and get a different lighting on this so I can actually read the output. Actually, I'm lying about that. I got to get a magnifier. Input is universal. Output is 12 volts, 200 milliamps. It says DC 3 to 12 volts, 200 to 200 milliamps. That's not very much, is it? So that's that. Got little twist ties on it, and they are twisted the appropriate way, which means you untwist them counterclockwise instead of clockwise. Sometimes I get twist ties that are twisted the wrong way, like this one is, where you have to twist it clockwise. That irritates the heck out of me. Oh, it's got a power control, a rheostat, or, I'm sorry, potentiometer. So I'm going to plug this in to my watt meter outlet, which I think you can see here. So we can see the wattage. It's got a green LED, so we'll let that sit for a little bit and continue to take this apart. Nothing else in the box. We've got an adapter plug, that's nice. We've got a metal bar, which I assume is the shaft it's going to ride on. Here we have, looks like a drive belt, chuck key, and Allen wrench. Allen wrench is probably to put it together. Let's see what we got here. Let me pull this out. It doesn't want to come out. Come on out, buddy. There's the motor and gearing and handle assembly. I gotta check my top camera. Oops, shaking my top camera around. Okay, so that's a spare belt. You can see it's got a belt right here. Now it doesn't have variable pulley positions as most drill presses do. My big drill press has one of those, and again, I'm using this. I wanted to try this because sometimes it's just not great to drag out the use the big drill press. Here's the handle. goes down. Oh gosh, it doesn't go down very far. That's like a ½ inch, some amount of millimeters. I'm going to go get a ruler. I'm sorry, I forgot to bring my ruler over. So let's give it a little go here. It will drill. It looks like it's got a throw of about 14 millimeters, or for those of us in the US, about ½ inch or so. This brass piece looks like, oh, it's going to be locking the shaft. Now where do I put the power in? Okay, power button is right there. That's where we'll plug that in. I'm not going to do that right yet, of course, because I'm not completely an idiot. One thing I am going to do is I'm going to use I have my RPM meter handy here. So I will put a little piece of reflective tape on the chuck. No, I'm not able to get it to adhere. So we're not going to do RPM. Oh well, I'll probably cut that little bit out. So let's see, what else do we have here. Here we have that. On the side it says in Chinese TZ525, operating voltage 2 to 12 volts, and then 0.3 to -4 millimeters. I assume that's what the chuck will take. Chuck's a little grindy, but we'll get that figured out. And here we have the base. Like so. And we'll put this shaft in the base. And that's what we have the little Allen wrench for, which I put somewhere. Oh, it's still in its little bag. So it's nice they gave us a spare drive belt, because I don't know if we will, if it goes bad. Wow. You really need to crank down this clamp for the upright. There we go. Oh, and this is the actual, I mean, this is just clamping it into the fixture, but the fixture itself is also loose. Right here, see that slopping around a little bit. So I got to tighten these other screws up. I'm getting my arm in the shot for the side shot. I'm sorry, I apologize. I'll just shoot from the top for a while. Okay, now we will put the motor on there. There we go. We'll do as high as we can. It's not quite as high as we could get, but that's what we're looking at. Let me move it up and down. Gosh, it really doesn't go very far, as you can see. I'm going to have to bring it way down to do some testing. So what will I do first? Let me grab a drill bit that will fit in there. I'm going to do a relatively small one. Use this one, which I got when I was working at Hydro Air down in Burbank in the US, working on aircraft components in their research lab. Got to get it in straight, of course. The chuck key works fine, even though the chuck does feel, as I said, it feels a little gritty, but I don't know. I'm going to take this down a little bit more from, ooh, it doesn't have a rack and pinion. Many drill presses have a rack and pinion that you can move the base up, the cutting portion up and down a bit. This does not. Okay. So we'll plug it in. Oh, I'm going to turn this all the way off before I plug it in. It's got an off switch. Cord goes around to this side, which means I'm going to have to watch out for it. And I will take this can of wood stain for a future project you'll be seeing. And let's see what we got. Let me turn it on. Sorry for the cross dissolve there. I got the footage back, or megabytage back to my editing computer. And I'm going to back this off just a little bit. And I realized my arm was getting in the way of the camera, so you couldn't actually see anything of what I was doing, so I decided to just reshoot it. So now we'll go ahead and again plug this back in. And we've got a medium-sized bit. Oh, let me get my calipers, for crying out loud. So this is a 2.8 millimeter bit, and we'll turn it on. Bring it up to about half. Let me go to the other side of this. Bring it up to about half, and that's about 12, 13 watts. And we'll bring the head down. And it's not, I didn't bring it down far enough. Again, that's a little bit of a challenge with this. The plunge depth is so shallow that you're going to have to get very precise about how you're using this. Take it up to about half and drills a very fine hole. It's a little stiff going in. Let me bring it up faster. That's 3/4 at 18 watts. And that goes right on in. Oop, but then it's stalled. Uh-oh. And as it stalled, the LED on the power supply went completely black, so obviously the power supply is not handling the overload very well. But that does that. That's wood. Worked very well. Got no complaints about that. Let's get, oh, I have to bring this back. I have to keep this here. Now I'm going to try a piece of plastic. Again, it's either plastic or acrylic. I think it's just plain old plastic. But we'll take that up to half. And it's making a fine hole. And as I look at it, there's no chipping, there's no irregularity in the hole. It looks just perfect. So that's good. So it works fine on plastic. I'm going to now do this little piece of metal. And I'm going to have to bring the, I mean, I could take the piece of wood out from under it, but I just do that to protect my bits and so on. Okay, now we're going to go up to about half again. Actually, I'm going to go full speed on this. This is aluminum. It's bogging down a little bit with this 2.8. Huh. It had to cool off or reset itself. Interesting. Well, it's not happy about that, or it's the drill bit. There, it overheated again. Hasn't reset itself. There it goes. So I'm going to swap to a smaller bit for this, just to see how, because it's really fighting me on that one. So wood and plastic, it worked just fine on. That, the aluminum, it's having a little bit of a problem. But again, it could be that bit is not sharp also. Again, some of these bits are 40 some odd years old, so I'll put that in and then run it up to speed so I can make sure the bit's in straight, and it is. Okay, now we'll try again with this bit, which is, let's see what this is. Still saying 2.8, which it is not. Basically 2, but bring it up again. And you can hear a little grittiness there. Let me bring the mic a little closer. So I don't know whether that's some gearing inside or something, but now we'll go ahead and do this one. And it overheated again. That's interesting. Let me go real slow. I'm going to go up to higher speed and go a little slower on my plunge. It really overheats and shuts down. So I'm going to take this bit out and go even smaller. Make sure it's centered. Nope. No, that's really not centered. I have to lay this down to get it completely inside the center of the 3. Try it again. Nope. Oh, and one thing you might have just noticed there, I put my hand on top, which is kind of dumb, because it impacted I put my hand on the drive belt. Fortunately, it's not like the mini chainsaw. Golly, this is hard to center. It's not like the mini table saw where you would really get hurt if you put your hand on the belt. Okay, so I really do have to set it on its side to guide it down in there to be completely straight. Check it again. Oh yeah, that's fine. Put my safety goggles back on. And I gotta lower the plunge height again. And now okay, for small holes it goes very quickly. It was just the large bits it struggled with. Now one more thing, let's do some circuit board material, because I have had to repair circuit boards in the past or put holes in where there weren't any. Take that up to about 3/4, it's 16, 17 watts. And I have to reduce the plunge height again. Again, that 14 millimeters is not much. Well, that worked very well. No problems there, ate right through it. So what I'm going to do is I'm going to do 2 things. I'm going to go to a bigger bit. I'm going to go to the max bit, and I found this in the previous videotaping or videoing that I did. So this is, it's showing 477. That can't be right. Oh, it is right. 0.477, which is bigger than the 0.4, I mean the 4 millimeters that they say is the max this chuck will take, but I discovered when I was doing this earlier today, on the footage that was all out of focus, that this is the biggest you can cram in here. You can get a 4.7 millimeter bit in here, that you do have to go kind of sideways. Don't have to worry about getting that straight. Now I'll bring the plunge up again because I'm going to go into the wood again. And again, it's not quite as stable. You can see the shaft is all tucked all the way down. Now we'll take it up to about, we'll go full speed on this, and this is a 4.7 millimeter bit. That's okay, but I want to go down a little further because it was just skating, as you saw. That works in wood just fine. Doesn't bog down. We'll try the, I'm going to turn that off. We're going to try the plastic with this bit. You might have heard it bog a little bit, but it did the hole cleanly. And again, no chipping. So I'm very happy with that. I'm going to try the piece of metal again, and I'm going to take that piece of wood away. I don't need it. And this will probably bog and get all uncomfortable with me. Let me get this off there. I'm going to try on untouched metal first. I'm having to move my hand uncomfortably. Well, it's eaten. That's eaten right through. I think I'm hitting kind of the side on that. Let me do a different location. And there, it overheated again, or overloaded again. Going to go full up. And I'm not putting much pressure on there at all. Let me get my finger so you can see. I'm barely touching it, and it's bogging down. So what I'm going to do is I'm going to move back here to where I have a small, you could almost call it a pilot hole, already drilled. See if that'll help us out. No, it doesn't have the power for that. And that's it. So it'll go through wood very well, seamlessly. It'll go through plastic. It'll go through circuit board material very well. It just struggles with heavier stuff. Even if I were to get mahogany or something, it might not go through the wood as easily. Didn't do well on the aluminum, so that means it's probably not going to even make a dent in steel. Let me try some of this. I'll try a piece just because I can. And while we've got everything set up, may as well mess with it. I mean, this is still the big bit. I don't even know if it's going to... This is a little cheapy wrench that came with some tool or kit or whatever. So I'm going to bring that way up. Huh. There, it overheated again. No, it's gets to a certain point and it's just too much. But this is a nice little unit. Again, for wood, for circuit board material, for plastic, I'm going to find it very handy. A lot less setup involved and a lot less space to have to deal with. It's pretty safe. The safety challenges with this one are the fact that this drive belt is exposed. It's not geared or anything, and it's got a lot of play, so even if it caught your finger, first off, I think it would stall. In fact, let me try that. While we're here, we'll do some science. We'll take this screwdriver and put it in here. And yeah, it pretty much stalls out. So if you put your finger actually in there, it's not going to be, it'll be like a pinch. It won't cut or whatever, or gear you up, and that's good. The other thing is, of course, it's very back heavy. This motor is causing it, it's really got a tendency to lean back. So you got to be careful about that, and I can't put my little clamps on that I use on other things. I might be able to, you could probably take these feet off and put it on a bigger base that would give you a little more stability. I don't think it's really worth it because, again, for what you're going to be using most of the time, if you don't have to put much pressure on it, it's very stable. So a good unit from what Innocraftsman cost about 120 US, I think it was, and a worthwhile tool for your shop if you need a little drill, if you need a little drill press to make precise holes in wood or plastic or circuit board material. I can certainly recommend this, and I hope you enjoyed the video.